Imagine this, a vast ocean, bigger than all of Earth's oceans combined. Not on Earth, not even on Mars, but hidden under the icy crust of a moon orbiting Jupiter. What if alien life is swimming there right now? That's the question the JUICE mission, the European Space Agency's $1.5 billion spacecraft, is designed to answer. Launched in 2023, it's now on an epic journey across the solar system, with one bold goal: to find out if the moons of Jupiter, Europa, Callisto, and especially Ganymede could be home to extraterrestrial life. This is the story of how humanity is about to peek beneath the ice, and maybe, just maybe, we're not alone. Why Jupiter's moons matter. When most people hear the phrase, "search for alien life," their imagination jumps straight to Mars. The dusty red planet has been the poster child for astrobiology for more than a century, inspiring everything from pulp science fiction novels to billion-dollar rover missions. However, over the last 2 decades, something fascinating has occurred. Scientists have shifted their gaze farther out, beyond the asteroid belt, into the realm of the gas giants, where some of the most promising environments for life may actually exist. Take Jupiter. This behemoth planet doesn't just dominate the solar system with its size. It also commands a retinue of 80 known moons. Most are small, icy, and forgettable. However, 3 of them, Europa, Ganymede, and Callisto, keep astrobiologists up at night. Europa is the crown jewel, an icy world scarred with long cracks and ridges that hint at a restless interior. Beneath its frozen shell lies a global ocean of salty water, possibly deeper than anything on Earth. Some researchers argue it may be the single best place in the solar system to look for microbial life. Then there's Ganymede, the heavyweight champion. Bigger than Mercury, this moon is massive enough to generate its own magnetic field, a rare trait for a satellite. Even more fascinating, scientists believe it holds multiple stacked oceans layered beneath the ice, each one sealed off from the next by sheets of frozen, rock-hard ice. Callisto, meanwhile, is the scarred elder. It's heavily cratered, ancient, and geologically quiet, a frozen time capsule of the early solar system. Yet even this battered moon may conceal a salty ocean deep under its crust. Here's the shocking part. Europa alone might contain twice the amount of water as Earth. And these oceans aren't warmed by sunlight, but by tidal heating, gravitational squeezing from Jupiter's enormous pull. That means they could host the same ingredients that made life possible on Earth: liquid water, chemical nutrients, and a steady source of energy. Mars may be dry and barren, but Europa, Ganymede, and Callisto? They may already be teeming with life. The JUICE mission. JUICE stands for Jupiter Icy Moons Explorer, a name that sounds almost playful, but the mission itself is anything but casual. This is the European Space Agency's most ambitious planetary project to date. A staggering €1.5 billion effort that brought together more than a dozen European nations, hundreds of scientists, and years of planning. The spacecraft began its journey on April 14, 2023, launching from French Guiana aboard an Ariane 5 rocket. But unlike Quick Trip to Mars, JUICE's destination lies much farther away. The spacecraft is now embarking on an epic 8-year odyssey across the solar system, weaving through complex gravitational slingshots before finally reaching the realm of Jupiter. And when it arrives, its mission is clear: focus on Ganymede. Why Ganymede? Because it isn't just the biggest moon in the solar system, larger even than Mercury, but the only known to generate its own magnetic field. This suggests internal complexity, perhaps even a deep saltwater ocean hidden beneath a crust of over 100 kilometers thick. If there is life in that hidden ocean, JUICE may be our first chance to detect its signatures. But Ganymede won't be the only stop. The spacecraft will perform 2 daring flybys of Europa, sampling its environment and peering beneath its cracked icy shell. It will also swing past Callisto, a remarkable 21 times, building a detailed map of its ancient surface and probing for signs of a buried ocean. This isn't just another robotic visitor to the outer planets. JUICE represents the first mission in human history dedicated specifically to the search for alien oceans. With every flyby, every scan, every data packet sent back, it is asking one grand question: could these frozen worlds actually be habitable? The science goals. So what exactly is JUICE looking for once it reaches Jupiter's icy moons? The mission isn't about flashy discoveries like snapping a selfie with alien fish. Instead, it's about answering fundamental scientific questions that bring us closer to knowing whether life could exist beyond Earth. ESA has laid out 3 major goals for JUICE, each one building a piece of the puzzle. 1. Search for oceans. We know that Europa, Ganymede, and Callisto are worlds of ice, but just how much ocean lies hidden beneath those frozen shells? JUICE carries ice-penetrating radar that will beam signals deep into the crust, bouncing back data that can reveal the thickness of the ice and the depth of the salty seas below. By mapping these hidden layers, scientists can confirm not just the presence of oceans, but their size, distribution, and structure. 2. Look for habitability. Habitability doesn't mean proving aliens exist. It means asking, could these moons support life, even in theory? JUICE will look for 3 essentials. First, liquid water is the universal solvent. Second, chemical ingredients like carbon, nitrogen, and sulfur, which are the building blocks of biology. And third, sources of energy, whether from tidal heating, radiation, or chemical reactions at hydrothermal vents. If these moons check all 3 boxes, they join the short list of worlds where life might flourish. 3. Study Jupiter's environment. Finally, JUICE will study the broader environment around these moons. Jupiter's powerful magnetic field, its dangerous radiation belts, and the complex distance of charged particles. This matters because even if the moons have oceans, the space weather around Jupiter may determine whether those oceans can stay stable and hospitable. In short, JUICE won't deliver pictures of swimming creatures, but it will deliver something equally important: the blueprint of habitability. It will tell us whether these icy moons truly hold the conditions for life, and, crucially, where to look next. Key takeaway number 1. More habitable than Mars. Here's something wild. For decades, Mars has been the golden child of astrobiology, the place everyone pointed to when imagining life beyond Earth. Countless rovers, orbiters, and landers have been sent to explore its surface, each one chasing the dream that microbial life might still cling to the planet's rusty rocks. But here's the uncomfortable truth. Mars today is a graveyard. It's cold, bone dry, and unprotected from the sun's harsh radiation. Any life that does exist there is likely buried kilometers beneath the surface, locked away in pockets that would be incredibly difficult for us to access. Now, let's contrast that with Europa and Ganymede. Instead of dry wastelands, they hide vast oceans of liquid water, oceans that may contain more water than Earth itself. Their thick icy shells act like natural armor, shielding what lies beneath from Jupiter's radiation belts. And unlike Mars, where surface energy is scarce, the moons of Jupiter have a built-in heating system, tidal flexing caused by Jupiter's immense gravity. That gravitational kneading could fuel seafloor hydrothermal vents, the very kind of environments where life on Earth may have first emerged. When you stack all of this up, a provocative idea emerges. Jupiter's moons may actually be better candidates for life than Mars. While the red planet offers a bleak hunt for long-dead microbes, Europa and Ganymede could be hosting dynamic ecosystems right now, beneath their frozen surfaces. If humanity's ultimate question is, are we alone? Then maybe we've been gazing at the wrong world all this time. The true answer might not lie in the sands of Mars, but in the hidden oceans of Jupiter's icy moons. The instruments on board. JUICE isn't just a spacecraft. It's basically a Swiss Army knife of science, packed with tools designed to peel back the secrets of Jupiter and its icy moons. On board are 10 carefully chosen instruments, each with a specific job, but together forming the most advanced scientific payload ever sent to the outer solar system. First up is RIME, the Radar for Icy Moons Exploration. This powerful radar can peer up to 9 kilometers beneath the ice, letting scientists map the hidden structure of Europa, Ganymede, and Callisto's shells. If there are pockets of liquid water or variations in the thickness of ice, RIME is the key to finding them. Then there's the JANUS camera, JUICE's high-resolution eye. It will capture sharp images of the moon's surfaces, cliffs, ridges, craters, and cracks, revealing geological activity and helping us piece together their histories. The MAGIS spectrometer comes next. With it, JUICE can analyze the chemical composition of the moon's surfaces, searching for salts, organics, or other materials that hint at what lies below. Alongside it is UVS, the ultraviolet spectrograph, which will sniff out thin atmospheres and potential plumes erupting from beneath the ice. Perhaps the most exciting for Ganymede is MAG, the magnetometer. Since Ganymede is the only moon with its own magnetic field, MAG will measure its strength and structure, giving clues about what's happening deep inside. Finally, the SWI, or submillimeter wave instrument, will study temperatures and chemistry, helping scientists understand how heat and materials move across these frozen worlds. Each of these instruments is powerful on its own, but working together, they turn JUICE into something unprecedented. Humanity's most comprehensive toolkit for exploring the mysteries of alien oceans. Key takeaway number 2, first to orbit Ganymede. Here's the historic milestone. For all of humanity's achievements in space, no spacecraft has ever orbited a moon other than our own. We've flown past dozens of them, taken snapshots, and even mapped some in detail. But when it comes to actually settling into orbit, Earth's moon has been the only one to host a long-term visitor. That changes with JUICE. By the year 2034, after an 8-year cruise and years of flybys through the Jovian system, JUICE will finally be captured into orbit around Ganymede. It will spend at least 9 months circling this colossal moon, becoming the first mission in history to treat a moon beyond Earth's as a true planetary destination in its own right. And the advantages of orbit are enormous. Instead of fleeting flybys, which offer only snapshots of data, JUICE will get the chance to observe Ganymede continuously. It will map the moon's entire surface in exquisite detail, track its complex magnetic field, and study how that field interacts with Jupiter's powerful magnetosphere. It will measure subtle shifts and flexing in the ice shell, the kind of movements that could betray the presence of a deep subsurface ocean. This isn't just another milestone to tick off a list. It's a fundamental leap in how we explore other worlds. By parking itself around Ganymede, JUICE will turn from a distant observer into a dedicated resident, living and working in orbit long enough to uncover the moon's secrets. And here's the bigger picture. Orbiting is always the first step toward landing. JUICE may not carry a lander itself, but every bit of data it collects will shape the missions that follow the ones that could finally touch down and explore the oceans of an alien world. The journey to Jupiter. Getting to Jupiter is no easy ride. Unlike hopping across town or even crossing to Mars, reaching the largest planet in the solar system requires a careful, years-long dance through space. JUICE can't just point its engines at Jupiter and floor the accelerator. If it tried, the fuel demands would be staggering, far more than any rocket could reasonably carry. Instead, engineers rely on a clever trick: gravity assists. A gravity assist works like this. The spacecraft swings past a planet at just the right angle, stealing a bit of that planet's orbital momentum and slingshotting itself onward with extra speed. It's interplanetary billiards, where each shot has to be perfectly lined up years in advance. JUICE's path looks more like a roller coaster than a straight line. In 2024, it will make its first Earth-Moon flyby, setting up its trajectory. In 2025, it will swing by Venus. diving closer to the Sun than Earth's orbit before being flung outward again. 4 years later, in 2029, comes the unusual Earth double flyby, where JUICE uses 2 passes at our home planet in rapid succession to build momentum. Then in 2031, it will make one final Earth flyby, a farewell boost that finally sets it on course for Jupiter. And in the summer of that same year, after looping through the inner solar system for nearly a decade, JUICE will at last arrive. Why so long? Because every kilogram of fuel matters. By carefully threading these planetary encounters, JUICE gets billions of euros worth of free energy. By the time it enters Jupiter's orbit in 2031, the spacecraft will have traveled nearly 600 million kilometers, a marathon journey to one of the most exciting destinations in our cosmic neighborhood. The big questions. Here's the heart of it. Whenever people hear about JUICE, the first question that pops into their minds is the most obvious one. Could it actually detect signs of life? After all, the idea of alien microbes swimming beneath Europa's ice or lurking in Ganymede's hidden seas is irresistible. But the honest answer is, not directly. JUICE isn't built to catch alien fish on camera or scoop up bacteria from a geyser plume. Its mission is subtler, but just as important. What JUICE will do will tackle the fundamental habitability questions, the ones that must be answered before we even know where to look. First, are the oceans really there? The radar and magnetic measurements will give us confirmation, mapping how thick the ice shells are and how deep the water goes. Next, are those oceans salty like Earth's seas? Salt content matters because it affects the chemistry and energy balance, making it easier or harder for life to survive. Then comes the question of chemistry itself. Are the building blocks of biology, carbon, nitrogen, and sulfur present in meaningful quantities? Without them, even oceans as vast as Earth's wouldn't matter. Finally, the most intriguing possibility. Could there be hydrothermal vents on the seafloor? On Earth, these dark, mineral-rich environments may have been the very cradle of life, providing heat and nutrients in total darkness. If Jupiter's moons host anything similar, they become prime candidates for alien ecosystems. If the answers line up in the right way, JUICE will do more than collect data. It will point the way forward, toward the next generation of missions, dedicated orbiters, robotic landers, and maybe one day, daring submarine probes that melt through the ice to dive into the alien oceans themselves. JUICE isn't the end of the search. It's the scout mission that tells us where to knock before we open the door. Key takeaway number 3, laying the groundwork for the future. Even if JUICE doesn't return a smoking gun for alien life, it is still a trailblazer in every sense of the word. Missions like this aren't one-shot events. They're stepping stones in a long, careful chain of exploration. What JUICE uncovers about Jupiter's icy moons will directly shape the strategies, designs, and priorities of every mission that comes after it. One of the biggest beneficiaries will be NASA's Europa Clipper, scheduled to launch in 2024. Clipper will perform dozens of flybys of Europa, swooping close to its surface to investigate its ice, its ocean, and its potential plumes. The spacecraft is like JUICE's partner in crime. While JUICE focuses heavily on Ganymede and Callisto, Clipper will zero in on Europa. The overlap is intentional. Together, the 2 missions will create a complementary data set, mapping the structure of ice shells, analyzing chemistry, and refining our understanding of which environments are most promising for life. But that's just the beginning. By the 2040s, the groundwork laid by JUICE and Clipper could lead to the next logical leap: a lander. A spacecraft designed to touch down on Europa's fractured ice and sample materials directly, possibly even sniffing the chemistry of an erupting plume. And beyond landers, the dream grows even bigger: robotic subs. Imagine machines capable of melting through kilometers of ice and diving into alien oceans, searching for hydrothermal vents and perhaps even life itself. That's JUICE's real legacy. It's not just about what it finds, but about what it enables. This mission is laying the foundation for the first real attempt in human history to answer one of the most profound questions we can ask: are we alone? The future vision. Fast forward to the mid-2030s. JUICE has finally completed its long journey and now orbits Ganymede, circling the largest moon in the solar system like a sentry. Its radar has pierced the thick icy shell and returned data that leaves no room for doubt. Beneath more than 100 kilometers of ice lies a global ocean, 150 kilometers deep, a body of water so vast it dwarfs Earth's seas. The discoveries don't stop there. JUICE's spectrometers detect traces of complex organic molecules scattered across the surface, materials that could be fragments from the hidden ocean below. Its magnetometer confirms that the ocean is salty and conductive, behaving not as a stagnant pool, but as a dynamic, living system. At the same time, half a solar system away, NASA's Europa Clipper is making history of its own. During one of its dozens of close flybys, the spacecraft captures evidence of towering water plumes erupting through cracks in Europa's ice. Instruments detect salts, organics, and perhaps even subtle chemical imbalances that resemble the signs of metabolism. Suddenly, the scientific conversation shifts. For decades, the question was, could life exist out there? Now the question sharpens into something far more thrilling and far more urgent. Are we about to find it? The search for life has always been the greatest quest of science, a pursuit that blends curiosity, philosophy, and technology into one daring human endeavor. With JUICE and with the missions that will follow, humanity isn't just speculating anymore. It's actively probing the places where alien oceans may thrive. JUICE may not be the mission that proves we are not alone, but it is the leap that makes that proof finally feel within reach. By the mid-2030s, the JUICE mission could give us the first real evidence that life exists beyond Earth. It won't be flashy, no alien fish selfies, but it could give us the data that says, yes, there's an ocean. Yes, it has the chemistry. Yes, it could be alive. And if even one alien microbe exists in the icy oceans of Jupiter's moons, it changes everything. Subscribe for more cosmic explorations and tell us in the comments, if we discover alien microbes under Europa's ice, what does it mean for us? Stay blessed and stay curious.